Hello everyone, welcome to Math World. This video is to discuss paper 3.5 for May-June 2025. So let's start with question number 1. So solve the equation 3 to the power 4 minus 2x equals to 5 times 6 to the power x minus 1. Give your answer equal to 3 significant figures. Okay, so 3 power 4 minus 2x. Just rewrite the question. So what we need to do here is to get the x. So since there is one term on both sides, therefore we just take ln both sides. Okay, so take ln both sides. Only one ln is allowed. Okay, so use the formula from ln or the properties from ln a power b, that is b ln a. For the left hand side, and for the right hand side there are two terms here, so we can split it into 2 ln, whereby ln ab is ln a plus ln b. Okay, so from here I will be getting 4 minus 2x times ln 3 equals to ln 5 plus ln 6 to the power of x minus 1. And again, for ln 6 to the power of x minus 1, we can just use the formula number 1. Then it will be ln 5 plus x minus 1 ln 6. Okay, so for the left hand side, we will just do expansion. So it will be 4 ln 3 minus 2x ln 3. Okay, so now at the same time, for the right hand side, I can do expansion for the last term. Here, just expand. Then you will be getting x ln 6 minus ln 6. Okay, so now we group all the x together. So which means I will be getting, okay, so this negative 2x ln 3 will be moved to the left side. Okay, move to the right side, and then the rest will be moved to the left side. So which means now here I will be getting x ln 6 plus 2x ln 3 equals to 4 ln 3 minus ln 5 plus ln 6. Okay, so now since the question asking for 3 significant figures, so for the right hand side I will just factorize the x. It becomes ln 6 plus 2 ln 3. And then for the left hand side, just rewrite, which means now my x can be easily found using 4 ln 3 minus ln 5 plus ln 6 divided by ln 6 plus 2 ln 3. Okay, then now here you will be getting the answer correct to 3 significant figures as 1.15. So that's all for number 1. Now question number 2, solve the equation 3 cotangent theta minus 4 cosec squared theta plus 5 equals to 0 for the theta defined from minus pi to pi. Okay, so since we have cosec squared and cot, therefore we are using the formula 1 plus cot squared theta equals to cosec squared theta. So I'm going to change this by 1 plus cotangent squared theta. So which means that you will be getting 3 cotangent theta minus 4 times 1 plus cot squared theta plus 5 equals to 0. And do expansion. 3 cot theta minus 4 minus 4 cot squared theta plus 5 equals to 0. Then from here, okay, I will simplify. So by moving all the terms to right side, it will be 4 cot squared theta minus 3 cot theta. So initially minus 4 plus 5 is 1, but you move it to the right side, becomes minus 1. And this quadratic equation can be simplified or can be factorized into cot theta minus 1 times 4 cot theta plus 1. Okay, so the cotangent theta is 1 or minus 1 over 4. So cotangent is basically tangent, 1 over tangent. So now 1 over tangent equals to 1. 1 over tangent theta is negative 1 over 4, which means now tangent theta equals to 1 or tangent theta equals to negative 4. Okay, so now solve for that interval minus pi to pi. So for the first part, minus pi means here, this is minus pi, and this is positive pi. Alright, which means now actually we are considering all 4 quadrants, but then tangent is only positive for first and third quadrant. Then the tangent is negative will be for second and fourth quadrant. So I need to find out 2 different basic angles. So here basic angle equals to arctangent 1. Now look at the interval. It is pi. Minus pi to pi, that means in radians. Then I can just leave it in pi over 4. Okay, which means here is pi over 4. And for the other one, basic angle is arctangent 4. Okay, the minus is just to show you the location of the angle. So from here, I will get 1.3258. I give more significant figures here. Alright, so which means my first angle is in the first quadrant, the second angle is in the third quadrant, and the other one, the first angle, okay, wait, because you have to be careful. Your theta is between minus pi and pi. That means instead of the third quadrant, we need to consider from the negative part, the bottom part, which means it should be over here. Okay, and then for the other one, be careful with the interval. These are the 2 angles. So which means now here I will be getting my theta as pi over 4, and the other one is basically negative 3 over 4 pi, because one horizontal line is pi, so the value itself will be pi minus pi over 4. That's why 3 over 4 pi. Okay, and the other one, the theta will be this, the upper one, the one on the above. Okay, that is pi minus 1.3258, and the other one is just a negative value. So then here I will be getting 1.8158 and negative 1.3258. So at last, your theta will be pi over 4, negative 3 over 4 pi, 1.8158, and lastly negative 1.3258. So this will be the solution of this question. Okay, now number 3. The complex numbers s and t are given. Okay, the s is in polar form and the t is in Euler form. Now A express s over t in the form REI theta, that is a Euler form, whereby the theta is in between minus pi and pi and r is greater than 0. So now what to do is, okay, so from the s, since you need to leave your answer in E form or Euler form, I can just express my s in Euler form. Okay, just for information, if let's say complex number a plus bi, it can be expressed as r cos theta plus I sine theta, and then this can be simplified into REI theta. Alright, so which means here I will be getting 5e I 0.25. Okay, so now your t is in the Euler form, so that's why s over t is basically 5e 0.25i over 6e 3i. Okay, so 5 over 6 just remain. The e, when you have division of same base, so we have another formula, ea over eb. This is going to be ea minus b. Then I will simplify it into e 0.25i minus 3i. Okay, then you will be getting 5 over 6 e negative 2.75 I. So now your theta, this is your theta. Okay, so your theta can be from minus pi to pi. That means this is your final answer. Okay, now B. In an Argand diagram with origin O, the points A and B represent the complex numbers S and S over T respectively. By considering the line segments OA and OB, or otherwise state the two geometric effects of dividing a complex number by 6E3I. Okay, so the 6E3I is basically the T. Alright, so now let's draw the Argand diagram. So imaginary axis and real axis. Now your OA, considering the line segments OA and OB. So OA is basically the S. So your S is this. Okay, that means the angle is 0.25 and then the length of the line is 5. So 0.25 probably here. Okay, the length is 5. This is 5 units. This is 0.25. That is your argument. And then the OB is S over T. S over T, the length is 5 over 6. And then the argument, okay, the angle is negative 2.75. So probably 2.75 is over here. Right? So this is only 5 over 6. The length is 5 over 6. This is your B. So this length is 5 over 6. And then here is 2.75. Okay, now, by considering this, okay, this is the O, then the origin is the O. State two geometric effects of dividing the complex number by 6E3I. Okay, so when you divide by 6E3I, right? So which means your A is S. Okay, so we have done this. It becomes 5 over 6, right? So that means, okay, so when S divided by T, that means it becomes S over T. This is 5 over 6. So E minus 2.75I. That means, okay, basically, you look at here. From A, it becomes B. So basically, from here, I know that this angle, when you plus together, okay, because now you need to find out, when you divide means that you minus the angle, right? So that means when you minus the negative 2.75, it becomes 3 here. Okay, so, and A to B, that means this is clockwise rotation. Alright, so that is the first. So I will say the effects geometric first is clockwise rotation of 3 radians. Alright, and then the second is the length. Look at the length for the OA. The OA initially was 5, but then once you divided by the T, this is actually the T, okay? Once you divided by T, that means it becomes the length of the B, so 5 over 6. So instead of 5, now becomes 5 over 6, which is 1 over 6 of the original length. Okay, so here I will write enlargement. Enlargement with scale factor 1 over 6. So these are the two effects. Okay, now next question, number 4. Find the exact coordinates of the stationary point for the graph. So your y is 3x cubed. Ln x degree 4. And stationary points means dy dx, alright, given x is greater than 0. So obviously this, you have to use a product rule. Product rule is d over dx, u times v, that is uv prime plus vu prime. So I will write u is 3x cubed, v is ln x degree 4. So for ln x degree 4, when I get the v prime, I will be getting over x degree 4. Differential x degree 4 is 4x cubed. Then we simplify, that is 4 over x. Then the du dx means u prime, which is 9x squared. Okay, so then from here, just apply the formula. Dy dx equals to uv prime, so 3x cubed times 4 over x plus 9x squared times ln x degree 4. And now let it be 0. But before that, I simplify first. So this is 12x squared plus 9x squared ln x degree 4. So dy dx equals to 0. 12x squared plus 9x squared ln x degree 4 equals to 0. So from here, the common term is 3x squared. If you factorize a common term, you will be getting 4 plus 3 ln x degree 4. And now, it's mentioned the x is greater than 0. So when x greater than 0, okay, obviously 3x squared cannot be 0. Okay, x greater than 0, 3x squared cannot be 0. Hence, the brackets must be 0. Otherwise, you will not get the product equals to 0. Then now, we need to get the x here. So the 4 can be brought down because we have the formula ln a power b, that is b ln a. So when you bring down the 4 and combine with the 3 here, that is 12. So I will get 4 plus 12 ln x. Okay, so divide by 4. 1 plus 3 ln x equals to 0. Then to get the x, get the ln x as a subject. So means that ln x is basically negative 1 over 3. And then the question asking for exact coordinates. So now my exact x, to eliminate the ln, take e both sides. So it will be e 1 over 3, negative 1 over 3. Okay, and now get the y. So the y, just substitute into the curve equation. So your y is 3x cubed ln x degree 4. So now replace. This is your x degree 4. So here it will be, okay, another formula, e a to the power of b. This is basically EAB, right? So which means this is 3e, will multiply minus 1. Then ln e, just multiply negative 4 over 3. And we have another formula, ln EA is a, to simplify the last term. Therefore, from here, I will be getting, this is 3 over e, then times 4 over, negative 4 over 3. So the 3 and 1 over 3 can be cancelled off. Okay, this one should be normal size. So the 3 and 1 over 3 can be cancelled off. Then at last, you will be getting negative 4 over e. So which means the stationary point, it will have the coordinates of e negative 1 over 3 and negative 4 over e. Okay, so done for this question. Okay, question 5. The diagram shows the locus of points representing the complex numbers z satisfying modulus z plus 5 minus 4i equals to 3. For the points on this locus, determine the maximum minimum possible values of modulus z. Okay, so now first of all, the equation. This is a circle equation, so I have to change to general form, which is z minus 5 plus 4i. Okay, once you get this general form, then you can identify the coordinates of the center and also radius. So basically, this will be giving you the center. So I know that center is with coordinates minus 5, 4, and radius is 3. Okay, which means now when I refer back to this diagram, basically center is minus 5, here is 4. Radius is 3, that means go up 3 units, go down 3 units. So when you plus 3 to the 4, which means here is 7. Okay, so you minus 3 from 4, this is going to be minus 1. Oh, sorry, it is 1. Okay, 4 minus 3 is 1. Then I know that here is going to be minus 2, and this point is going to be minus 8. Okay, this is the diagram. Now the question asking for maximum and minimum for the modulus z. The modulus z is actually counted from the origin, and that is the length. Okay, so obviously the smallest. Okay, now what to do here is I need to join, because it's always counted from the origin. Right, counted from origin. Then I know that the minimum will be here. This will be the minimum. Okay, whereby the maximum will be up to here. This is a maximum. Right? So just calculate up to the origin. So what we need to do now here is we know that this is radius 3. Here is also 3 from the center. This is a center. Okay. Then now I need to find out, let's say my center is C. So I need to find out what is my OC. Then I minus a 3 minus a radius. That will be my minimum modulus z. If I use OC plus 3, which is this green color, then it will be the maximum modulus. Okay, so to find out the OC, very simple. It forms a triangle. Look at here, triangle. So OC is here, right? That means this is 5 units. Going up is 4 units. Okay, so from here, I will write my OC is basically square root of 4 squared plus 5 squared. Okay, because the length is 5. So here is going to be 3. Then now my minimum. Okay, so minimum modulus z, that is going to be OC minus the radius. So OC minus radius. So that is mistake. Square root of 4 squared plus 5 squared is square root of 16 plus 25. That is going to be square root of 41. Okay, so this is square root 41 minus radius is 3. And now the maximum of the modulus z based on the diagram, it will be the OC, which is the purple color OC plus the radius. That is the furthest distance. So here OC plus radius. Therefore, square root 41 plus 3. Okay, now B. Find for the points on this locus, determine the minimum possible value of argument z. Argument is the angle. Okay, so now our minimum, okay, so basically the argument, you have to refer to this. This is the minimum, right? Because it's counted from this side. And then here must be 90 degrees, which means now you need to find out what is this angle. So when I need to find out this angle, I know that I have the triangle C, this point, and the O, and together with the blue color triangle, which is this, right? So if I redraw the diagram, it looks like this. Okay, here is the 90 degrees, and then this is your C. Right? And now we need to calculate this angle. What is this? This is the argument Z, the minimum. Okay, so then another one is a C. From the C, I can draw a triangle. Because we know that the coordinates of C are -5, 4. That means here is 5, this is 4. So which means now here I can find out what is this angle. Let it be alpha. Okay, and just now we have counted the OC. The OC is square root 41. That means this is square root 41. And this C to the point here, this is radius, which means it's 3 units. Okay, so this is 3 units. Okay, then again, I can find this angle, which is a theta, which means I know that addition of these three values, argument z, theta, and alpha, it will be pi. So which means now I need to calculate theta and alpha. But you must understand that both are right angle triangle, so we can use a sine cos tangent formula to get the angle. Okay, so this is square root 41. Now when you refer to the theta, it's actually 3 is the opposite side. Okay, 3 is the opposite side of the theta, and then square root 41 is the hypotenuse. So opposite and hypotenuse is basically sine. So I will write sine theta is 3 over square root 41. Then my theta is going to be arc sine 3 over square root 41. And same goes to the alpha. So the opposite side is 4. The adjacent side is 5. Okay, so I can use tangent alpha. That is 4 over 5. Or probably you can use the square root 41. Then that is the hypotenuse. So from here, my alpha will be arctangent 4 over 5. Okay, so my minimum argument z is going to be pi minus theta plus alpha. So pi minus theta is arc sine 3 over square root 41. And then alpha is arctangent 4 over 5. So change the mode of the calculator into radians, then you will be getting 1.98 as the final answer. Alright, next question, number 6. Given the parametric equations, show that dy dx may be written as a cosec 3t, where a is a constant to be found. Okay, so this is parametric equations. Here I can simplify 1 over cos is basically second. Okay, then your y is tangent 3t. dy dt, differentiate tangent is secant squared. The remain 3t, differentiate 3t is 3. Now, your dx dt, when you differentiate secant, that is secant 3t tangent 3t. And then differentiate 3t is 3. That means here it's going to be 6 secant 3t tangent 3t. Okay, so now use a chain rule. dy over dx equals to dy over dt times dt over dx. You can use this way, or probably you can just write dy over dt divided by dx over dt. So I will use a second formula. So which means your dy dx is basically the division of 3 secant squared 3t and 6 secant 3t tangent 3t. So now you simplify. We need to get our answer in a cosine 3t. So 3 and 6 simplify. Degree 2 and degree 1 cancel. Then I will be getting 1 over, oh sorry, not 1. You still have degree 1 for the second. So secant 3t over 2 tangent 3t. But when you look at the question here, we need cosine. Cosine is 1 over sine. So better change all into sine and cos. So the second itself, okay, at first the over 2, I will factorize becomes half. The second is 1 over cos. Okay, then this over tangent 3t is basically cotangent. It's same as 1 over tangent 3t you times. So therefore it becomes cos 3t over sine 3t. So now the cos 3t will be cancelled off. Okay, and you will be getting half 1 over sine. 1 over sine is cosine. So therefore your A is half. Okay, so done for this question. Now find an equation of the normal to the curve where t is 1 over 12 pi. Give your answer in the form y equals to mx plus c, where m and c are exact. So just now we have found dy dx, right? So basically, to form a straight line, we need the x and y coordinates. So better find the x and y first. 2 over cos 3t. So this is 2 over cos pi over 4. This is going to be 2 over 1 over square root 2. Then you will get 2 square root 2. The y is tangent 3t. So here becomes tangent 3 times pi over 12. This is tangent pi over 4. Tangent pi over 4 is 1. Okay, so now here I get point. The coordinates of the points will be 2 square root 2 and 1. Okay, now equation of normal needs gradient of tangent. So dy dx. dy dx, just now we have found half cosec 3t. So it is half cosec 3t. Then you replace. Cosec is 1 over sine. 3t is 3 times pi over 12. So this becomes half 1 over sine pi over 4. Okay, then I will be getting 1 over 2. And this is 1 over root 2. So you are actually getting, this is root 2, okay? The 1 over root 2 is root 2, so root 2 over 2. And now this is a gradient of tangent, so m tangent. Normal line is perpendicular to tangent line, so m normal will be negative 1 over m tangent. So I'll get negative 1 over square root 2 over 2. At last, you'll be getting negative 2 over square root 2. And this can be simplified into the 2 you change to square root 2 times square root 2, then over square root 2. So at last, negative root 2. Okay, so with the points and the gradients, then you can form the equation of normal. It will be y minus y1 equals to m bracket x minus x1. This is a straight line equation, or probably you can just write y equals to mx plus c. So y minus 1, the m is minus square root 2, x minus 2 square root 2. And now do expansion. Just do expansion for the right side. You just times. Then you will get minus root 2x. Minus is a plus. Root 2 is 2. 2 times 2, 4. And the minus 1 on the left hand side will be moved to right side, becomes plus 1. So at last, y is negative root 2x plus 5. So that's all for the solution of this question. Alright, now next question, number 7. The equation of a curve is y equals to arctangent 4x. Find the exact values of x when gradient of the curve is 1 over 4. So the gradient is basically dy dx. So it means y is arctangent 4x. Okay, so dy dx, to differentiate arctangent x over a. Okay, this is going to be a over a squared plus x squared. Okay, so from here, arctangent 4x means that it will be arctangent. Okay, probably I change to another form because we need to get x over a. So this is like arctangent x over 1 over 4. So that my a is 1 over 4. Okay, so dy dx, it will be arctangent. Dy dx is going to be a over a squared plus x squared. Okay, so when you simplify, this is going to be 1 over 16 plus x squared. And now you get the same denominator for the denominator over here. So it will be 1 plus 16x squared, but divided by 16. So when I simplify, this is going to be 1 over 4 times 16 over 1 plus 16x squared. So this is going to be 4 over 1 plus 16x squared. Okay, this is our dy dx. And now the question is asking for, okay, find the exact x when the gradient is 1 over 4. So now what I need to do here is dy dx is 1 over 4. So now I will write 4 over 1 plus 16x squared equals to 1 over 4. And now just cross multiply. 4 times 4, 16 equals to 1 plus 16x squared. And now rearrange to get rearrange to get x squared on one side, then the number on the other side. So I will be getting 16x squared equals to 15. So your x squared will be 15 over 16. Your x will be plus minus square root 15 over 16. Then here is going to be plus minus square root 15 divided by 4. Okay, so let's look at the question. Okay, so there's no special rule for the x. Therefore, this will be your x value. Okay, now B, find the exact value of the integration. So the y is arctangent 4x. So to integrate arctangent 4x, we don't have a formula. What we need to do is we change it into by parts, because from the previous formula or from the previous part, if your y is arctangent 4x, we can differentiate, okay, to get this result. So that means if I use by parts, my u will be arctangent 4x. So it is the same as 1 times arctangent 4x. That means my 1 will be the v. Okay, so the by parts formula is basically integrate u dv dx equals to uv minus integrate v du over dx. Right, if with limits, then just add on the limits on the right side. So then from here, my u is arctangent 4x because from the previous part. So I know that du dx, copy the answer from previous part, which is our dy dx. So 4 over 1 plus 16x squared. And then the dv dx is 1. So your v is to integrate the 1. Therefore, you get x. And now use a formula, uv. So multiply and minus integration of v du. So v du dx means when you multiply, so I get 4x over 1 plus 16x squared. Okay, so for the first term, just replace the x by 0.25 and 0. So you will be getting 0.25 arctangent 4 times 0.25 minus 0. Because the x is 0, so everything is 0. And then for the integration over here, I'm going to use the ln because the degree of the denominator is 1. Okay, it's 1. So according to ln formula, we'll differentiate the fx to get f prime x in the numerator. Then this will be ln fx plus c. So when I differentiate 16x squared, I will be getting 32x. So here, so I'm getting 32x. So I have 4x from the previous part. That means I need to times by 1 over 8 to get back the original integration. So which means now here I will be getting 0.25 arctangent 1 minus 1 over 8 ln of the denominator and with limits. So you can include the 1 over 8 or you can just factorize the 1 over 8 when you do the integration, when you replace the values. So from here, 0.25, the arctangent 1 is basically pi over 4. Okay, so when it is pi over 4, instead of writing 0.25, I will change it into 1 over 4 then. So minus 1 over 8. Then replace the x by 0.25 first. This is ln 1 plus 16 times 1 over 4 squared minus ln 1 plus 0. Then here you'll be getting pi over 16 minus 1 over 8 ln, okay, 1 over 16 squared is 1 over 4 squared is 1 over 16. So 1 over 16 times 16 is 1. So therefore ln 2 minus ln 1. So the ln 1 is basically 0. Okay, and the question asking for exact value, therefore just leave it in pi and ln form. So done for this integration. Okay, next question number 8. A. By sketching a suitable pair of graphs, show the equation has exactly one root in the interval x between 0 and half pi. So now second 2x equals to negative 2x minus half. That means my y1 is second 2x. My y2 is negative 2x minus half. I need to show that there is only one intersection point. But then the second is basically 1 over cos. So I have to refer to the cost graph. And now you refer to the interval from 0 to half pi. Okay, so for the cost graph, if it is cos 2x, okay, I use other color as rough work. Cos 2x, this is cos 1x, cos 2x. Here is 2 pi. And this is half pi. This is minus 1, here is 1. This is your cos 2x. But then since now we just sketch the graph from 0 to half pi, that means I will just consider up to here. Okay, this is a graph that I'm referring to. So for the second 2x, okay, what I need to do now here is for second 2x, from 0 to half pi. So look at here, when x goes to 0, 1 over 1 is going to be 1. Okay, for my second 2x. And then at this point, which is pi over 4, this is pi over 4, it is 0 for the cos. So 1 over 0 is infinity. So when it is pi over 4, it tends to infinity. That means this is the asymptote. And this one going down, so it will be going up. Okay, and from pi over 4 to pi over 2, so when pi over 2 it is minus 1, so 1 over minus 1 still minus 1. This is our pi over 2. So I'm getting this point, but then this one going down, so 1 over going down is going up, and it is from 1 over 0 means from infinity, so from negative infinity going up. So this is my cosine. Second to x. And now for the y2, okay, y2 it is a straight line. So when x goes to 0, my y is minus half. So it's here. This is minus half. And then when my x equals to half pi, my y will be negative 2 times half pi minus half. This is minus pi minus half. So you must remember pi is 3 point something, right? So this is more negative. That means probably here. So I'm getting this point. Okay, so now join these 2 points using a ruler. Okay, and then we don't extend the graph. Our graph starts from 0, x equals to 0. That means it's supposed to be here. It's a straight line. Alright? Just up to pi over 2. So that means there's one intersection point here. So this is the straight line. So just right now, there is only one intersection point. Hence, okay, the question says, has exactly one root. Hence, second to x, or hence, the equation has exactly one root. But this is only for that particular interval. Okay, so done for this graph. Okay, B, by calculation, show that the root lies between 0.8 and 1.2. So now we refer back to the equation. This is the equation, and rearrange it So I will write second 2x equals to minus 2x minus half. So now move all the terms to the left side to get all positive. So I will get second 2x plus 2x plus half equals to 0. So to show the root lies between the two values, I'm going to use the sign change rule. So I define my fx first. And now calculate both values. When you do calculation, you have to change the mode of the calculator into radians because it is second, okay? So this is this is going to be negative 32.1, which is less than 0. And for the other value, so second is 1 over cos, okay? So 2 bracket 1.2 plus 2 times 1.2 plus half. Then this is 1.54, which is greater than 0. And from here, I found that there is a sign change. So there is a sign change. Hence, the root lies between 0.8 and 1.2. So, shown. Okay, now see, show that if a sequence of real values given by this formula converges, it converges to the root given in the part A. So basically, it means that you need to show from this formula until you get the equation in your part A. So that means equation needs second to x. So we need to rearrange. Firstly, ignore all the subscripts. So first of all, times 2 to the whole equation. And then move the across to the other side. And now, when you refer to the A, we need second to x. Second to x is basically 1 over cos to x. So I will just take 1 over cos. I use 1 over the left and right side. So 1 over cos 2x, it will be 1 over negative 2 over 4x plus 1. And then here will be second 2x. This is 4x plus 1 over negative 2. Okay, now we have found the second 2x, but now for the right side, we need two terms. We need minus 2x and minus half. So now, what to do is you split the right side into two terms. So at last, you will be getting minus 2x minus half. And this is same as second 2x. So we have shown. So done for this question. D. Use this iterative formula to calculate the root correct to 3 decimal places. Give the correct answer, give the result of each iteration to 5 decimal places. Okay, so first of all, just copy the formula. Okay, and now for the initial x, you can just refer to part B. So since the roots lies between 0.8 and 1.2, then you can choose any values in between or just take these two endpoints. So I'm going to take the midpoint, which is 0.8 plus 1.2 divided by 2. That is 1. So now calculate as 1. Okay, so the calculator should be in the radians mode, and then here you will be getting 0.99116, 5 decimal places. So then the final answer 3 decimal places, just check here. So now x2 will be half at cos -2 over 4 times 0.99116 plus 1, and this is 0.99271. Okay, so when you check, 991 becomes 992. So we need to continue for x3. This will be half at cos -2 over 4 times 0.99271 plus 1. And this is going to be 0.99244. Okay, so now even though these two are the same, but the previous one, we should refer to the previous one for the final answer. So the previous one, when you round up, it is 993. So better find one more to double confirm. So x4. And then you will be getting 0.99249. Okay, so 3 decimal places and you round up, it is 992. So same as the previous. That means now basically the answer is based on the previous. Okay, so now my final answer is 0.992. Okay, question 9. Express this in partial fractions. So 12 x squared plus 55x minus 2 over 3x minus 2 times x plus 6. Okay, so be careful with this because when you do expansion for the denominator, it's actually x squared, right? This is a quadratic function. But then numerator also quadratic, same degree, that is improper rational function. That means we need to perform the long division before the partial fractions. So now what we need to do is do expansion first. So you just expand the denominator, you will be getting 3x squared plus 16x minus 12. And now perform the long division. So 12x squared plus 55x minus 2. Then the divisor 3x squared plus 16x minus 12. Okay, so in order to get 12x squared from 3x squared, we need to times 4. So 12x squared plus 64x minus 48. Then after that you minus. So the first one will be 0. 55 minus 64 is basically minus 9. Then minus 2 minus 48 is actually minus 2 plus 48. Then you will be getting plus 46. And this is our remainder, okay? So now I will be getting 4 plus. So I rearrange, that is 46 minus 9x over the quadratic. So quadratic, I will rewrite the two factors. And now I need to find the partial fractions for this proper rational function first before I add with the 4. So 46 minus 9x it will be a over 3x minus 2 plus b over x plus 6. Okay, so now get the same denominator. So I need to times by another factor in both the numerator and denominator, which is x plus 6. And then plus with b over x plus 6. So you times by 3x minus 2. Okay, then now since they are having the same denominator, just refer to all the numerators. And now let the factor be 0. So let x plus 6 be 0. Therefore, the x is minus 6. Now I will get 46 minus 9 times minus 6 equals to, so x plus 6 is 0. Then we can find the b. 3 times minus 6 minus 2. And now here you will be getting 100 for the left side. Right side will be minus 20b. Then my b is going to be minus 5. Same goes to the a. To find the a, let the factor of b be 0. So let 3x minus 2 be 0. That means your x is going to be 2 over 3. So the left side, just replace. Then now you will be getting 40 for the left side, and right side is 20 over 3a. Then now my a will be 40 times 3 over 20. That is going to be 6. Once you have found the a and b, substitute back into the 46, the proper rational function. So it will be a over 3x minus 2. Your a is 6. So 6 over 3x minus 2 plus b. But the b is minus, so plus and minus becomes minus. Now this is not yet the original, not yet the final answer. You need to plus 4. Okay, here. Right? So just copy back the question, 12x squared. Then there will be 4 plus the previous answers. So done for the partial fractions. Now B hence obtain the expansion including x squared. Okay, so hence means use the previous answer. Six over and minus 5 over x plus 6. So to do expansion, we have to move up the denominator. Okay, so when I move up, just for information, we are going to use a binomial expansion. So make sure the constant is the first term. Okay, now according to the binomial expansion, this is a formula whereby the n is real number, it must be 1 and it must be plus. So here 1 plus nx plus n minus 1 over 2 factorial x squared. Okay, so I just consider up to x squared. So then here we need to make minus 2 into 1. That means you factorize minus 2. So 3 over minus 2 is negative 3 over 2. The whole term, power negative 1, minus 5, and 6 plus x, make it 1 from the 6. So factorize the 6, 1 plus x over 6. Then now here, 4 plus. Okay, the power of minus 1 must bring into both. Okay, both terms inside the square bracket. Which means now here, I will be getting minus 2 power negative 1. So whatever term with degree of negative means 1 over. So 1 over negative 2. Then I will do expansion. This 1 minus is basically 1 plus negative 3 over 2x. because the second rule is plus in the expansion. So here it's going to be 6 power negative 1, so 1 over 6. And now we do expansion. So 6 times negative half, that is negative 3. So 1 plus, your n is minus 1, your x is negative 3 over 2x. Plus n minus 1 over 2 factorial, then the x squared. Okay, then followed by minus 5 over 6. 1 plus n is minus 1, your x is x over 6. Plus n minus 1 over 2 factorial, x over 6 squared. Okay, so now we simplify. So I've simplified all the terms inside the square bracket first. It will be 1 plus 3 over 2x plus 9 over 4x squared. Okay. Minus 5 over 6, bracket 1 minus x over 6. And then the whole term is plus x squared over 36. Now expand the 3 substitute this 3 or times this 3 inside into the square bracket. So you will be getting, and don't forget there is a negative here, so all becomes negative. Okay, same goes to the other one, times the minus 5 over 6 into the bracket. So you will be getting minus 5 over 6 plus 5 over 36x minus 5 over 216x squared. So at last, simplify. 4 minus 3 minus 5 over 6, that is 1 over 6. Okay, then the coefficient for x becomes minus 157 over 36. And last term, so this will be your expansion. Okay, now we move on to question number 10. With respect to the origin O, the points A, B, and C have the position vectors. It's given that the magnitude of AB is same as the magnitude of BC. Find the value of B. Okay, so now get the vector AB first. Vector AB is basically OB minus OA. So I will express in the vertical form, that is B minus 2, 3, minus the OA is 2 minus 1 minus 6. Then combine together, it will be B minus 2 plus 1, minus 1. 3 minus 6 is 9. And then the BC is OC minus OB. Minus 4, 5, minus 2, minus the OB will be B minus 2, 3. Okay, then this is going to be minus 4 minus B, 7 minus 5. So now the modulus will be the same. So modulus AB, same as modulus BC. It will be square root of B minus 2 squared plus minus 1 squared plus 9 squared, then equals to square root minus 4 minus B squared plus 7 squared. This is the formula for modulus. Means you square all the components and plus. So to eliminate this, very simple, just square both sides. So the square and square root cancel. Now do expansion to get the b. So I will be getting b squared minus 4b plus 4. Minus 1 squared is plus 1. 9 squared is 81 on the left side. And right side, you will be getting 16 plus 8b plus b squared. 7 squared is 49. Square of minus 5 is plus 25. Okay, so basically, when you simplify, the b squared will be cancelled off. Okay, so I will group all the b on the same side. So I will move this minus 4b to the right side. It will be okay, or probably I don't want to do this first. I simplify first because there are so many constants there. So what I need to do here is minus 4b, 81 plus 5, that is 86. Then 16 plus 45 plus 49 plus 25, that is 90. So 90 plus 8b. Okay, then group the b one side becomes 12b, and then 86 minus 90, that is minus 4. That means now my b is minus 4 over 12. That is minus 1 over 3. Okay, now b. A, B, C, D are the vertices of a rhombus. Find the position vector of D. Okay, so we just simply sketch, but in this order A, B, C, D. So let's say A, B, and then C, D. In the order A, B, C, D. Okay, rhombus. So it means that they are parallel to each other. So I will say that AB equals to DC. And now we need to find OD. So we have found the AB just now. We can just direct use. The AB is basically this. And replace the replace the B. Okay, so I will get B minus 2. So B is minus 1 over 3. So I will get negative 1 over 3 minus 2. And then minus 1 and 9. Then this is OC minus OD. And now to get the OD, just move the OD to left side and then this one to right side. So that means your OD is basically OC. So replace the OC now. OC will be minus 4, 5, minus 2. Okay, and then your minus. Okay, this minus 1 over 3 minus 2 is basically minus 7 over 3. And then minus 1 and 9. So when you minus, simplify it, it will be minus 5 over 3, 6, and minus 11. So that is your OD. Okay, so now calculate angle ABC. So when you refer to this, the previous diagram, angle ABC means here. So we need two vectors, BA and BC. Okay, I will let this be theta. Alright, so I will write let the angle ABC be theta. So based on previous diagram, I know that the two vectors will be BA dot BC. Okay, the BA and the BC. So according to the scalar product formula, it will be BA dot BC equals to magnitude BA, magnitude BC cos theta. So BA, go back to the previous part. Okay, this is your AB. You know that AB and BA just the opposite direction. So means I times minus to the whole vector. So first two value will be positive and the 9 will be negative. So this is 7 over 3, 1, negative 9. And then my BC we have solved just now. BC is this value. So then replace the B by negative 1 over 3. So basically the first one is minus 4 plus 1 over 3. Then you will get minus 11 over 3. So here I will write minus 11 over 3. And then the other two components will be 7 and minus 5. Okay, just copy from the A. Now the modulus of BA, okay, go back. We have solved just now. Modulus of BA basically, okay, we know that, is it magnitude BA, magnitude AB same as magnitude BC. So magnitude BA is also same as magnitude AB, right? So which means you can either find the magnitude for these two separately, or I could say that it is the same magnitude for both. So you multiply. So probably I will just use this method because they are the same. And then you multiply by itself. That means you times 2. Okay, then cos theta. Now for the dots product, now you have to multiply. So 7 over 3 times negative 11 over 3 plus 1 times 7 plus minus 9 times minus 5. Then for the right side, square and square root cancel off. So you get 49 over 9 plus 1 plus 81 cos theta. Okay, so the left hand side, it will be 391 over 9. Then the right hand side, 787 over 9 cos theta. So your cos theta is 391 over 787. And then the question asking for angle. Angle means what is a theta? So the theta is basically arc cos. So arc cos 391 over 787. Then this is going to be 60.2 degrees. Okay, done for the angle. Question 11, given the differential equation and y0, x0, solve the differential equation and find the y when x equals to 2. So now, x squared plus 3 dy dx equals to e3y times x minus 2. So the y should be on the left side. That means the e3y will be moved down. So it becomes 1 over e3y dy equals to x minus 2 over x squared plus 3 dx, and integrate both sides. So for the left hand side, you can change to e negative 3y. And then for right side, because you have two terms in the numerator and two terms in the denominator, so I will split. So x over x squared plus 3 dx minus integrate 2 over x squared plus 3. Okay, so now for left hand side, no problem to integrate. For the right side, the first term, since it is degree 1 here, and when I differentiate x squared plus 3, I will be getting 2x. So that means here I can use the ln formula. Okay, but for the second integration, I cannot use ln because when I differentiate x squared, I will not get constant. So the second one, you have to use the arctangent because of x squared plus a number. So now, just for information, we are going to use these two formulas to integrate the right side. And then the other one is going to be integrate 1 over x squared plus a squared. This is 1 over a arctangent x over a. Okay, or probably the a you can write in the numerator for the previous, for the left hand side. So which means now I will be getting the right side first term when I differentiate x squared plus 3, that is 2x. To get back x times half. Okay, then here I will factorize the 2 to make it to 1 for the numerator, and denominator must be x squared plus a squared. So it becomes 1 over x squared plus square of square root 3. Okay, change to this form first before you use the formula. Then now I will solve the left side to integrate e minus 3y, that is e minus 3y over negative 3. And the first term on the right side is half ln x squared plus 3. So I put a modular sign here to make sure it is positive. Then minus 2. And this is going to be 1 over, now your a is square root 3. Then arctangent x over square root 3. Then plus c. Okay? And now replace x by 0, y by 0 to get the c. So when x equals to 0, y equals to 0, e0 is 1, so 1 over negative 3 is half ln, x is 0, so becomes ln 3, minus this is 2 over ln 3, 2 over square root 3, arctangent 0 plus c. So basically arctangent 0 is 0. Then I will be getting my c now. So my c is negative 1 over 3 minus half ln 3. Okay, so the question asks for solve. So it means that now just need to replace the c. Replace here. So e minus 3y over minus 3 is half ln x squared plus 3. We know that it is positive because of x squared. So no need to put the modular sign if you are confirmed that it is positive. Then minus 2 over root 3 arctangent x over root 3. Copy the c. So replace the c. Okay, done for the solution. Now the question asking for x is 2, what is your y? So when x is 2, e negative 3y over negative 3 half ln 2 squared plus 3 is 7 minus 2 root 3 arctangent 2 over root 3 minus 1 over 3 minus half ln 3. Okay, basically here you can just calculate how much is the right side. Then give more decimal places. I will get 2.698038. And now e minus 3y, just times the minus 3 to the right side. So you times minus 3, that is going to be, okay, wait, this minus 3, okay, I will say this value is after I have multiply by minus 3. Okay, there's some mistake here. That means now here, okay, I'm getting this now. Then to get the y, eliminate the e by taking ln both sides. Okay, so probably the best way is this one. I just ignore it. I show you step by step. So I move up the minus 3 before I give you the answer. Okay, so you move up the minus 3. Then here will be half ln 7 minus 2 over root 3 arctangent 2 over root 3 minus 1 over 3 minus half ln 3. Okay, this value is going to be 2.698038. Now to eliminate the e, you have to take ln both sides. So when I take ln both sides, minus 3y same as ln of 2.698038. Then now my y move down the 1 over negative 3, so it will be negative 1 over 3 ln. Okay, and the question is asking for the y value. So just round up the value to 3 significant figures. So this is my y when x equals to 2. Okay, so that's all for this paper. And that's all for the video. Thanks for watching. Please continue subscribing this. Please continue supporting this channel by sharing this channel with your friends, and stay tuned for more upcoming videos. Thank you everyone. Bye.